Solutions to assignment questions. Question 13 to 21. Question 13. The Victoria Harbour is stormy or wavy and not a calm, smooth surface. The pool of water on the left is calm, which is a plain surface that produces regular reflection that forms clear images. Question 14. How to mark the path of a light ray? Mark the path of a light ray by two crosses, as widely separated as possible. Then connect the two crosses and mark the light ray. Question 15. How to identify different light rays? You should mark different light rays with different symbols: single arrow, double arrows, stars, squares, and so on, or simply use different color pens. Question 16. A bigger or a smaller protractor should be better. A bigger protractor is certainly better. Since the scale is bigger, you may then read the angle measurement from the scale more easily and accurately. Question 17. Green leaves are green. Why? All colors of light are absorbed except green. Green light is not absorbed but reflected. So we see green light and the leaves appear green. Question 18. You are given the absorption spectrum of chlorophyll, so you may know what colors of light are absorbed by chlorophyll. For this question, you must refer to the given diagram. It tells us that chlorophyll absorbs mostly blue and red light, and it does not absorb green light. So green light is reflected, and since green leaves have a lot of chlorophyll inside, green light is reflected by green leaves. Question 19. This is a similar question as the last one, but this time it is a t-shirt. For this question, the t-shirt absorbs mostly yellow light and green and orange light, but not red and blue. From your book on page 16, you can find blue and red light combined to give magenta. Question 20. These two diagrams show regular and diffuse reflections. On the left is regular reflection. On the right is diffuse reflection. Draw the normal in these cases. In both cases, the incident rays are all parallel. For the left picture, the surface is a plain mirror, a smooth surface that produces regular reflection. So the normals are all vertical. For the right picture, the surface is not smooth. This is diffuse reflection. You have to draw the normal in each reflection carefully. The normal should always be a line just between the incident ray and the reflected ray, so that the angle of incidence and the angle of reflection are the same. Question 21. For sure, it is the most difficult question. It asks how much the reflected ray has turned when the mirror turns. First, this is the reflected ray when the mirror is horizontal. Then the mirror is turned by an angle theta. The reflected ray becomes this red arrow, and you can easily find the angles there. So, by comparing the two reflected rays, one in black and the one in red, their directions are different. The angle between them is 2 theta. That's all for the solution part. Let's move on to the new pages. Open your book and start copying the notes carefully. 2.4 Image formation by plane mirror. In the last lesson, you have learned that only regular reflection produces images. In this lesson, we will investigate how images are formed by plane mirror. Do you still remember how we describe images? Images can be erased or inverted, magnified or diminished, or has the same size as the object. So what about images formed by plane mirror? Are they erased or inverted, magnified, diminished, or has the same size as the object? They all have the same size as the object, and they are all erased and laterally inverted. So, how is an image produced? Why plane mirror images are always erased, but laterally inverted? Is it annoying sometimes? It may be for some people, and that's why the word ambulance on the front of an ambulance is printed this way. Let's look at how a point image is formed. 2.5 Formation of point image. A point object produces a point image. We see ourselves in a mirror. Well, in a mirror. Where is the image? Is it really in the mirror? Physicists say it is behind the mirror. Let's find out why they say so. So, this will be the experiment. A more difficult one than the last one about the laws of reflection. So, let me explain a bit here. You will be given a worksheet which look like this. Stand the mirror along the line MN. Mark a point O on the top left. This is the point object. Then turn on the ray box. Direct a light ray through the point O. Mark the reflected ray. Repeat with another light ray that also passes through the point O. Repeat one more time if you have time. Produce the reflected rays backward. They should meet at a single point. Yes, all the reflected rays should appear to come from the same point. This point is called image. Let's mark it as image I in the ray diagram. So we see that a point object produces a point image. And where is the image? Draw a line between O and I. How is the line OI and MN related? Also note that we should draw virtual rays using dotted lines. Please note that when light rays from the object are reflected by the mirror, all the reflected light rays appear to come from the same point, the point image. However, we usually need only 2 light rays to find the image position. Therefore, any 2 reflected light rays should be good enough to locate the image accurately. In the coming lesson, your teacher will also show you a simple experiment called Method of No Parallax. You will find it interesting. Now let's revise how to locate a point image. First, draw the incident ray. Use a protractor to measure the incident angle. Measure the reflected angle so that you may draw the reflected ray. Produce it backward. When done, repeat with another incident ray. Use a protractor again and find the reflected ray. Produce it backward So there's a point of intersection, and this would be the image I. So it's a bit clumsy. It takes so long to finish the ray diagram. Is there a better way? Let me show you. From the above experiment, you may notice that the object position, the mirror, and the image position are related as shown in this diagram. First, the line OI and the mirror MN are perpendicular. Second, the object's distance and the image distance are the same. So, I suppose it is now easy for you to locate the images in the following cases. Let's try. The images, there. And how about this one? The images, there. And this, and how about this? Well, when the image is located, then you may draw the ray diagram in this way. First, draw the virtual rays connected with the reflected rays, and then lastly, the incident ray to complete the ray diagram. Let me do that again. Virtual rays, reflected rays, incident rays, no projector. Let me do that again. Virtual rays, reflected rays, incident rays. Virtual rays, reflected rays, incident rays. So, in order to draw a ray diagram, first of all, locate the image. Then, draw the virtual rays, reflected rays, and lastly, the incident rays. Easy, right? 2.6. Nature of image formed by a plane mirror. In daily life, things around us are usually not point objects. They have size, they have length, they have width, they have height. They are extended objects. So how to locate the image? How to locate the image of an extended object? And why images formed by plane mirrors are laterally inverted? To locate the image of an extended object is not difficult. You just have to locate the images of the ends of the extended object, like this. This is A. This is the image of A dash. This is B. This is the image of B dash. So the whole image of the extended object AB is A dash, B dash. Sounds easy, right? What about the character P? Similarly, we may locate the images of its different ends first. So this P becomes a Q, small letter Q, a big one. We can see that the images formed by plane mirror are always erect, which means upright, and laterally inverted, which means left side right. Also, these images cannot be projected onto a screen. We say the images are virtual. Virtual rays and virtual images should be drawn with dotted lines. Lastly, there are solutions to questions 1 to 9 for those people who have to do their recorrections. And there are also solutions to question 10 to 12, which is given here for your reference. All these questions are about the use of the formula d equals vt, where d is the distance traveled, v is the speed of the motion, and t is the time taken. That's the end of the video. See you. Bye-bye.